You're standing on the deck of a ship, far from land. The sun dips below the horizon, painting the waves in fiery gold. Suddenly, a hush falls over the world. The water beneath you vanishes. In an instant, the endless blue expanse is gone, replaced by nothing but thin, whispering air. Your vessel plummets into an abyss, the wind howling as you fall toward a newly exposed, jagged seafloor miles below. This is no dream. This is the nightmare we're about to explore. What if, in a single, inexplicable moment, every drop of water in Earth's oceans, 361 million square kilometers of liquid, holding 97% of our planet's water, simply ceased to exist? Not evaporated, not drained away over eons, but instantly substituted with the same volume of breathable air. The seas, the gulfs, the trenches, all transformed into vast, empty chasms filled with the invisible gas we take for granted. This isn't science fiction. It's a thought experiment grounded in physics, biology, and geology, revealing the fragile threads that bind our world together. At the heart of this cataclysm is the ocean itself, or rather, its absence. The world's oceans are a colossal reservoir, averaging 3,700 meters deep, with the Mariana Trench plunging to nearly 11 kilometers. They contain 1.332 billion cubic kilometers of water, a mass so immense it shapes the very crust of the Earth. Now, replace that with air. Air, with its density of just 1.2 kilograms per cubic meter, compared to water's 1,000, offers no buoyancy, no support. What was once a liquid cradle for life becomes a yawning void, a planetary scar, exposing ancient ridges, volcanic vents, and forgotten shipwrecks. The properties of this change are brutal in their simplicity. Gravity remains unforgiving, pressure gradients shift wildly, and the delicate balance of our atmosphere unravels. The consequences? Immediate and irreversible, rippling from the depths to the skies. In our real world, the oceans are the beating heart of Earth. They drive the water cycle, evaporating to form clouds that deliver rain to continents. They absorb half of the carbon dioxide we emit, mitigating climate change. Phytoplankton alone produce up to 70% of the oxygen we breathe, more than all the forests combined. Historically, oceans have shaped civilizations, enabling trade, feeding billions, and even influencing wars through naval power. Scientifically, they're a buffer against extremes, moderating temperatures so that coastal regions stay habitable while inland areas swing wildly. Naturally, they're a biodiversity hotspot, home to 94% of Earth's living species. Without them, we lose not just water, but the engine of life itself. Compare that to our scenario, a barren, air-filled expanse where none of this machinery exists. The contrast is stark. A thriving blue planet versus a desiccated husk, echoing the lifeless deserts of Mars. Now, let's walk through the unraveling, step by step, as this horror unfolds. In the first seconds, chaos erupts. Every marine creature, from the tiniest krill to the mightiest blue whale, suffocates in the dry air. Billions of tons of biomass flop lifeless onto the exposed seafloor, beginning a massive die-off. Ships at sea, submarines, oil rigs, they all free fall into the chasms, crumpling on impact amid clouds of dust. Coastal cities witness the sea retreating in an instant, but not like a tsunami. No wave surges back. Instead, a vacuum pulls air and debris toward the voids. Within minutes, the atmosphere responds. The ocean basins, now empty, become the lowest points on Earth. Air rushes in to fill them, creating hurricane-force winds worldwide. Pressure drops dramatically on land as the global air mass redistributes. At higher elevations, like what were once coastal cliffs, oxygen thins, making breathing labored. The sudden loss of water weight triggers isostatic rebound. The Earth's crust, relieved of trillions of tons, begins to rise in some places, sink in others, sparking earthquakes and volcanic eruptions along fault lines. Hours pass and the climate collapses. Without oceans to evaporate water vapor, the hydrological cycle grinds to a halt. Clouds dissipate, rains cease, Rivers and lakes, starved of replenishment, dry up swiftly. Global temperatures plummet at first without the ocean's heat storage, then skyrocket as unchecked solar radiation bakes the land. Day-night swings become extreme, scorching days, freezing nights. Dust storms rage across the newly arid continents, blotting out the sun. Days turn to weeks, ecosystems crumble. Terrestrial plants wither without rain. Forests burn in wildfires fueled by dry air. Herbivores starve, carnivores follow. Humanity scrambles. Billions reliant on seafood face famine. Fresh water sources vanish, leading to mass migrations and conflicts over dwindling reserves. The ozone layer weakens without oceanic halogens, exposing life to lethal UV radiation. Oxygen levels drop as phytoplankton perish, slowly asphyxiating survivors. Months in, the planet transforms. The empty ocean basins become hypersaline deserts, their floors cracked and barren. Continents, now perched like plateaus above these abyssal plains, experience thinned atmospheres, equivalent to living at 8,000 meters altitude, where hypoxia sets in. Volcanic activity surges, releasing greenhouse gases that trap heat, pushing Earth toward a Venus-like runaway greenhouse effect. Life clings on in isolated pockets, deep aquifers, polar ice if it survives the initial melt, but extinction looms for most species, including us. In this shattered world, we see the ocean's true power, not as a mere body of water, but as the guardian of equilibrium. It sustains biodiversity, stabilizes climate, and even sculpts the geology beneath our feet. Without it, Earth becomes a cautionary tale of interdependence, reminding us how one element's removal cascades into oblivion. But what if this fate isn't inevitable? What hidden forces might alter the outcome or hasten it? Ponder that as we delve into our next What If.